University of Skövde, we have strong expertise in smart manufacturing optimization, digital twin, and human-machine collaboration. And the big advantage is we always co-create solutions in collaboration with industry, meaning that we test and implement solutions in a real-world environment close to the real-world need that makes the solutions much more practical on the shop floor. One of the key factors to address these challenges could be close collaboration between academia and industry. While industry could bring hands-on practices and knowledge, academia could help with research background and providing a state-of-the-art solutions.
The main benefits for Volvo to work with academic researchers, it is to expand from our internal life with more in-depth research areas and deep research. So we have internally, we work with the short, mid, long-term development. And here we can connect this with academic research, and together we can learn from each other, and it's a win-win. And why Skövde then? Why the University of Skövde? Skövde is a small enough university to be flexible and agile, but also big enough, or I should say strong enough, to deep dive into some certain development areas where we need to have a long journey in many years. And I know it's benefits both for Volvo and the University of Skövde to be able to do that together. So flexible and strong.
This tool is an advanced simulation-based decision support tool. It provides a dynamic replication of the real-world production system. So managers and production engineers can use this tool to have a projection of their production process, to find inefficiencies and define the improvement measures for the system. The benefit of this tool is that production engineers and managers can detect bottlenecks in the system, and by taking non-capital intensive decisions like replacing mobile resources and changing buffers in the system, they can improve the performance of the system like throughput and working process and other important production measures. This tool can help manufacturers to be competitive in the ever-changing manufacturing environment. They can use the analysis based on this tool to optimize the production process and improve the throughput of the system using data-driven capabilities inherent in the simulation model.
One of the tools that we developed in our recent collaboration with industrial partners is an advanced augmented reality system combined with artificial intelligence and computer vision that is not only for visualization or visualizing instruction, but also for understanding and interacting with the shop floor environment. This kind of digital tools can enhance human capabilities by providing visual instruction and also giving instant feedback. So it will provide operators with much more confidence and significantly reduce their stress level when it comes to new products or new development.
I would describe the collaboration between Dalok and the University of Skövde as a sort of mutual benefit. I think that Dalok provides a very interesting case study in terms of production and single unit assembly lines, whereas the University of Skövde provides us with a sort of insight into how we can make our production more adaptive, which is something that we're continuously striving for. One successful research collaboration which was done with Dalok was simulating the conveyor systems at our factory. So initially we had very little in ways of calculating how many products were moving through the conveyor systems. Instead it was made manual. Now with simulations we can automate this process, which is something that has led to better means of keeping track of where products are and how they're moving through the factory and how we can balance them.
During the past years, we have been actively collaborating with industry in developing digital optimization tools for balancing production lines. And in a very recent collaboration work with automotive industry, we developed a decision support tool for balancing machining lines that are among the most complex production environments. Using this tool will help production planners in industry to act more quickly to changes and also help them to be more efficient when it comes to utilization of resources. Another augmented reality tool that we develop is for managing and adjusting safety zones when it comes to collaboration with robots. We know that when we have a robot, there are safety zones, but those zones are not visible to operators or to users, and it's not easy to adjust them. This tool is not only limited to manufacturing industry. As we see these days, collaborative robots are used and can be used in many different places, in hospitals and in schools. We may even have collaborative robots in the future at home, and this tool could come very handy when it comes to the improving safety and defining the boundaries for a robot. When we work in academia, we may develop great models, tools, and solutions that may work perfectly, but probably will not satisfy the requirements of the real-world need. On the other hand, when companies face complex challenges, they might not have the time or the right tool to address those. Collaboration between academia and industry could bridge this gap, helping us to come up with some both innovative and applied research.